Welcome to episode 2 of the TechPub series, Introduction to Android. In this episode, I'm going to cover the Android architecture, which is important to know when building Android applications. Before we can build an Android application, it's important to understand the architecture behind Android. So let's take a few moments to do a quick deep dive into the Android architecture. First, we start with the Linux kernel. Android is built atop of the Linux 2.6 kernel. And the reason why Android was chosen to run on top of Linux is because it has a proven driver display model, built-in networking, security features, and it's very robust and has been proven time and time again. On top of that, we have the libraries. Now these libraries include the Surface Manager, which is on the left-hand side here. The Surface Manager coordinates how to get the pixels to the screen. So this includes drawing the views, drawing bitmaps, drawing various different things on the screen. The libraries also include OpenGL and ES. These are for drawing 3D dimensional graphics. SGL is for drawing 2D dimensional graphics. The majority of the drawing that happens in Android is through SGL. However, it's important to note that you can also draw 3D and 2D at the same time. The media framework was provided by a member of the Open Handset Alliance, and that includes the codecs for playing video and audio. We use the FreeType system for our fonts, etc. I have SSL. Data storage is supplied by SQLite, and it's also important to note that if you don't prefer SQL databases, you can use the object database DB4o. Under the hood, we use the WebKit browser, and sitting alongside of this is the Android runtime. At the base, we have the Dalvik virtual machine. The Dalvik virtual machine runs .dex files, .dex files. These are compiled Java code, compiles down to an intermediate language, and the Dalvik virtual machine will run the dex files, which is compiled within the .apk. When you compile an Android application, you have a .apk file, which is the Android package itself. And on top of that, we have the core libraries that you can program against, and that's in the blue box here. These core libraries include file libraries, networking, I/O, etc., graphics and drawing, and so forth. Atop of the Android runtime and the libraries, we have the application framework. The activity manager is responsible for handling activities. Each activity is considered basically one screen. We'll get into that shortly. Package manager handles how the packages are going to be managed once they're inside of the Android system. This would include the different types of applications you may have installed. Telephony manager is responsible for making phone calls, receiving phone calls. The window manager is responsible for handling how windows are displayed on the screen. Resource manager is the manager that is responsible for handling any embedded resources or any resources for that matter inside of your application. Bitmaps, audio, video, etc. are all considered resources inside of Android and are therefore handled by the resource manager. Everything inside of the resources area is compiled down into a R class, so it's R dot whatever, R dot strings, R dot drawable being a bitmap, etc. Content providers are a way for Android to share data between applications. The location manager is responsible for handling GPS updates, notifying you when the GPS information changes, if it's a cell tower, GPS, or even Wi-Fi network that you're getting the information from. The view system is how different elements on the activity are laid out. This includes buttons, text boxes, list boxes, etc. And then we have the notification manager. The notification manager is responsible for displaying a rich UI to the end users through the status bar on the Android phone. You can program to this to supply status bars, progress notifications, any other icons in there as well. And on top of the entire system, we have the applications themselves. Here we have home, contacts, the phone, and the browser, and the ... here would signify any other application that would run on the Android platform. This is where you'd code an application. This is where I'd code an application. We sit on the top layer here in the applications. There's a few Android application building blocks we need to talk about. They're activity, intent receiver, service, and content provider. These are the 4 building blocks of how you're going to build Android applications. The first is an activity. It's a UI component that typically corresponds to one given screen. So let's take, for example, you want to open the Gmail application. When you open the Gmail application, you would then receive the mail list. The mail list here is an activity. So now we're playing with one activity. If we select a message such as hey everyone, we actually start another activity inside of the same thread. And here we're actually looking at the mail message itself. So this might be the mail message activity. Multiple activities can be spawned from within an application at any given time. The second topic is intent receivers. Intent receivers respond to notifications or status changes, and they can wake up your processes. A good example of an intent receiver is going to be when a phone call comes in. Perhaps you would like something to happen. An intent is fired off letting you know that the phone state has changed and your application would like to do something. In this instance, perhaps you would like to display custom user icons from Flickr. So if your friend calls you, you can connect up to Flickr and perhaps maybe you have a local cache of the images from their Flickr account, and it randomly displays one of their pictures when they call along with their name. The third is a service. A service is a faceless task that runs in the background of Android. The perfect example of this is the music service. When we start the music application, the music that was playing at that current point in time isn't actually running in the foreground. It's actually running in the background on a service. The music application just connects to the background service and sends it messages telling it what to do. You need to pause, stop, fast forward, rewind, etc. So the important thing to note here is that a service has no user interface whatsoever. The last and final component we have here is the content provider. Content provider enables applications to share data. So at the bottom in the blue, we have contact data, mail data, and even some custom data. This could be data that you have pulled from a third-party resource, maybe Twitter, etc. You can provide this information, expose it through a content provider. Various applications that sit above can connect into the content providers, pull contact data, the mail data, any type of custom data, and kind of aggregate and mash it up and use it inside of your application. So it's just a way for you to provide content to your users and to your applications. So to recap here, we have the activity, which is a UI component typically corresponding to one screen, an intent receiver, which responds to notifications or status changes, and it can wake up your processes when certain things happen. We have a service, which is a faceless task that runs in the background, and a content provider, which enables various applications to share data between them. This is really important to note, which segues us into how we are going to replace and reuse applications. On the left-hand side of the screen here, we have various applications that may need to use perhaps a picture. The home application, which displays when you start the phone, you might want to change the background image. So that's one way you could use an image. You may want to attach an image to a piece of mail in Gmail. In the contacts, you may want to set a picture of someone that you know that you have, so you may need to use a picture there. And SMS or MMS, you would need to send a picture to a friend, etc. So they all use the gallery. What happens when you would like to attach a picture to an MMS? When you open the MMS application, the MMS application is saying hey, I would like to pick a photo to attach the MMS. And what happens here is the client component makes that request to say, hey, I'd like to do this. That's known as an intent. An intent is a key piece of functionality from within Android. At that point in time, the system's going to pick the best component for what can handle that intent. At the current time, at the current implementation, maybe your stock Android phone is going to use the gallery to choose that. The best part about this is these components can be replaced at any point in time. So if you would like to perhaps provide a different type of gallery, you can implement a gallery that is pulling information or pictures from Flickr. So the next time the pick photo intent is fired off, it provides you with a gallery that actually goes to Flickr. And this could be reused across the home, mail, contacts, MMS, and any other application that might use the pick photo intent. Intents are key to the Android operating system. And the reason being is intents provide the messaging system of how you would like your applications to interact with one another. As seen on the screens, these are various different types of intents that might get fired off. We may want to play a song, we may want to edit the calendar, browse the market, capture a photo, get the GPS location. The options are endless, and there's literally hundreds upon thousands of intents once you start getting into custom applications of things that you can do. The application lifecycle in Android consists of various different apps. Each app runs within its own processes, and Android manages these processes, and Android may reclaim any resources that it needs at any given time. Therefore, if perhaps 2 applications or 3 applications or even 1 application is highly intensive on CPU or memory, Android can decide to reclaim those resources by killing off the applications. And this is good to know because no application can consume all the CPU or memory at any given time. This allows us to make sure that the phone can keep operating and do its basic features, such as being a phone, accepting or receiving text messages or sending them, etc. So what we're going to do is we're going to walk through a basic application lifecycle. So we're going to start with the home application here, and from there we're going to navigate into a Gmail application. We're going to open up the app. We're going to view the list of messages inside there. We'll then select the message. From there, inside the message, we'll assume that the user clicks on a HTML link, which will open the browser. At that point, the user may be looking at the web page and it has a map address on there, and they click on the address, which then starts the Maps application. Now, these are 4 different applications that could be written by 4 completely different people, but however, through the intent system, the applications are seamless to the end user. The end user doesn't have to know anything about what's happening behind the scenes in regards to firing up the app and navigating. The only thing that they know is that they went to their email, they opened the email, they read the email, they decided to open the link, they looked at the web page, they wanted to see a map. To the end user, it seems like it's all the same application, but you're actually using perhaps 4 different applications to do that. So let's walk through this process at a high level to understand what's really going on. So here on the screen, we're working with the home application. Before we can continue on and start the mail application, we save a little parcel of information. This is a bundled information that's stored in the system process that says, here is the exact state of where I left the home application. So later on, if I need to come back and rebuild the home application, I can do so. And we'll get into that in a second. So now we start up the mail application. We're viewing the mail list here. And again, we're going to take an information of parcel information, shove it up into the system process saying, now before I can actually look at the piece of mail that I'm looking at from the list of mail, I would like to save some parcel information stating, here's where I'm at inside of the Gmail application. Now this information that's stored isn't the entire application state. It's just metadata about what's happening in the application. Now this may be information of certain preferences, it may be where you're scrolled to in the screen, etc. So we're saving this in the system process just in case we need to keep it for later to rebuild that app and put it back in the same state that it was before. At this point, we're going to go ahead and look at the message, the Gmail message. So we're 2 steps in. And the next step may be to open the browser. Again, to do so, we're going to need to save the state of the message view, the message activity. So we have actually fired up 3 applications here. We have a few activities that are saved: the home, the mail list, and the message itself. The mail message has now saved its state into a parcel, stored it in the system process as well. Now the browser is open. The user is viewing the browser, they're reading the web page, etc. They see a link on the web page that perhaps is an address, and then it decides it needs to fire up the map application. However, it's important to note that we need to actually save the state of the browser again to continue, just in case we need to reclaim some resources. We can rebuild our activities and applications again. So we save our state here. The next component is, if we notice there's no more room on the screen, this is to signify that we don't have any more memory that's available. So what we need to do is we need to clean up some memory. To do so, we can't get rid of the browser because the user is currently in the browser viewing a web page. However, we can discard the message and the mail activities that are currently running. They are currently saved, their metadata, in the parcel information stored up in the system process area. Android destroys the mail activities and creates some extra room inside of the application. So then all of a sudden it pops something back onto the stack, fires up the map application, and now we're actually viewing the map. This parcel information is very important to understand because we are now saving state of where we are at in the application. The reason for this is when we want to return back to the home application or maybe even the Gmail message, we need to remember how to get back to that location, which piece of mail to open when we're looking at our message, where we were at when we scrolled to it inside of the mail list, and maybe what screen we were on the home screen. Were we on the far left screen or the far right hand side, or we scrolled over twice, etc. So let's assume that the user is done viewing the map now. Once the user is done viewing the map, they will back out of the map, and then we're going to actually destroy that map application and reclaim the memory because we didn't have any memory that was available. Android will now recreate the mail messages, and then we're going to step back and look at the mail message after we back out of the browser. And as we can see here, the parcels are disappearing off of the icons up top. And what's happening is Android is taking that parcel, unbundling it, seeing what metadata is inside of there, and restarting the activity with that metadata, the saying, here's where you were at before, go ahead and rebuild yourself. Now if we back out of the message, we're going to show the message list, and there's the message list, and we will destroy the message on the stack. And now we're looking at the message list, which is just our Gmail application. And if we decide to back out of that, we're now going to be back to our home application, and there's nothing really left on the stack at this point in time. This is how a basic application fundamentals work inside of Android. Things are on the stack, it's going to reclaim resources it needs to, it's going to save bundled information inside of its system process. At that point in time, it'll keep track of where it's at, destroy and reclaim memory as it's needed, and then as we back out of an application or step backwards, it will rebuild the application based upon the metadata that's stored within the system process inside of the parcel information for that activity. At that point in time, we're back to our home application and we can continue on to another application. Thanks for watching episode 2. In the next episode, we're going to cover introduction to the emulator and how to set up various different emulator environments to mimic the various different devices you'll find out in the real world.